Okay, in this video, I want to go over this practice handout on the production function, which is a production function. We're going to say this is it for an economy here called Polyland, where output is just a function of capital and labor. And this is the production function here, AK to the 1.1 power and labor to the 0.3 power. And the question first is, does it produce constant returns to scale? And the answer here, no, it doesn't. And you know that because the exponents do not add up to 1. We've got 1.1 and 0.3, which is 1.4. So it's not constant returns to scale. It'll actually be increasing returns to scale. Double all the inputs and we'll have more than double the output. We can show that by taking the production function, AK to the 1.1, labor to the 0.3, double labor and capital, and see what happens. So if we double capital, we'll have 2 times capital to 1.1, 2 times labor to the 0.3. And we're going to have the same technology that exists, the same total factor productivity. Nothing's going to change here as far as corruption in the economy or property rights or anything else that would affect output that's included in that A category. So this is going to be A times 2 to the 1.1, K times to the 1.1, times 2 to the 0.3, labor to the 0.3, which is 2 to the 1.4 times A times K to the 1.1 times L to the 0.3, which is equal to 2 to the 1.4 times AK to the 1.1, L to the 0.3, which is Y. So we have 2 to the 1.4 times Y. Not equal to 2Y. So we don't have constant returns to scale. Do we have diminishing returns to capital and labor? And how do you know? Well, labor is to the 0.3, capital is to the 1.1. So if we draw output here in capital and show what happens as we increase capital, there's not diminishing returns. It's going to plot something like that. So if we hold labor constant and total factor productivity constant, we increase K, we don't have the diminishing returns kind of a slope. We have an increasing returns. If we were to plot labor on the horizontal axis and output on the y-axis and hold capital and total factor productivity constant, we're going to get a graph that looks something like this. Showing the diminishing returns because that exponent on labor is less than 1. So this will have diminishing returns. To labor. And over here, this is increasing returns to capital. Now, if we took the partial over here, we would get partial y, partial k. We would get a times L to the 0.3 times 1.1 times k to the 0.1, which is greater than 0. But the second derivative is going to be 0.1 times a to the L to the 0.3 power times 1.1 times k to the negative 0.9, which is also greater than 0. So the slope is positive and increasing, meaning increasing returns. Over here on labor, took the partial derivative y with respect to labor, we get a k to the 1.1 times 0.3 L to the negative 0.7, which is greater than 0. Slope is positive. But the second derivative, to see how that slope is changing, is negative 0.7 times 0.3 times a times k to the 1.1 L to the negative 1.7. And this negative 0.7 out here on the front makes the term negative. So this is less than 0. So the second derivative is negative, meaning the slope is decreasing. Positive but decreasing because of the diminishing returns. Now the next question says, what happens to the marginal product of labor, which is the slope of this curve on the right, when total factor productivity, A, is increased? Well, if we increase A, then this whole curve is going to shift up like that. We can produce more at every level of labor. So at any particular level of labor, we'll call it L here, we can go see what the marginal product of labor is. And with an addition to A, the total factor productivity, that might come about because maybe a increase in technology. I'll draw the slope there. And if I've done it halfway decently, we should see that that blue line has a steeper slope than the red line, meaning that marginal product of labor is higher. Now remember that marginal product of labor is the derivative, which we said was 0.3 times A times k to the 1.1 divided by L to the 0.7. That would be right up here. That's our marginal product of labor. And you can see what happens is A increases, the numerator increases, and the whole term increases. Meaning as we add A, the marginal product of labor increases, or the slope of that line increases.